Today on Capecchi's Corner, we're going to look at operations with matrices. Now, this is the first lesson when we're dealing with different matrices, so we're going to do a lot of foundation work today. So a matrix is a rectangular array of variables or constants in rows and columns, usually enclosed in brackets. Now, each element is each value of the matrix. The matrix has several values in it, so they're each called elements. And the dimensions, they are very important, especially going forward when we're going to start to multiply. Dimensions, they describe a matrix. So if I say an m by n matrix, a 3 by 2, a 7 by 5, they are m rows and n columns. So we'll talk about that. All right, so the first thing we're going to start with is just the basics of adding and subtracting. So each of these things here, they're each a matrix. Okay, so we're going to add and subtract some, we're going to add and subtract some matrix along the way. So to add or subtract them, they must have the same dimension. So whether it's a 3 by 2 or a 4 by 5 or a 4 by 3, they have to have the same number of elements. So for instance, when we're adding, we're just going to add the first element of each, like this one's the upper left, and we're going to put them together, and then we'll add the next two, and they're going to go together, and so on. Same thing happens when we're subtracting. Upper left there. We're going to do that. We're going to subtract them. So let's start with an example. Okay, so find each of the following. For A is equal to, and then it gives us A's matrix, and then it gives us B, and it also gives us C. So when I want to add A and B, I am first going to start again with my brackets. So I'm going to start, I have 16 plus -4, that gives me 12. And then I have 2 plus -1, that gives us 1. And then I have -9 plus -3 gives us -12. And then I have 8 plus -7 gives us +1. Now, if I'm going to subtract them, I have to be careful of the order. So for here, I'm taking B minus A, even though A is listed first. So if I stay using the same colors, -4, this time for B, I'm going to go -4 minus 16, right? That's going to be the first one. That's going to give me -20. And then if I'm dealing with my reds, I'm going -1 minus 2, which gives me -3. Looking at my light blue, I have -3 minus a -9, so it's going to be +9. So it gives me 6. And then my last one here is -7 in purple minus 8 gives me -15. Okay. Now, when I want to add A and C, so let's kind of get rid of all of this. If I want to add A and C, the problem I have here is this is a 2 by 2, and here I have 2 rows and I have 1 column, right? Rows go this way. They go here. Columns go up and down like the columns of a building. They go up and down. So I can't add them because they are not set up. They don't have the same dimension. So I can't add them. So I just say not possible. This is not possible because it's not the same dimensions. Okay, so that's a basic adding and subtracting. Now we're going to look at some basics of multiplying. We're going to multiply by a scalar. And what that scalar is just something that I'm going to multiply each element by k. So you can see here, here's the symbol. If I have that number in front, I'm going to multiply each, whether it's, in this example here, you can say it's -3. So each element gets multiplied by that. So here's an example here. I multiply each element by -3, and I'm going to come up with my new matrix. All right, so let's try one. I have R. I'm going to multiply everything by 5. 5 is my scalar. So let me set up my matrix. So -12 times 5 is -60. Now, if you want to write 5 times -12 to hold that place, you can. If you feel like you can do it in your head, that's fine as well. And it doesn't matter here if I go across or if I go down because everything is getting multiplied by 5. So it doesn't really matter the order in which I do it. So that gives me -80. -16 times 5 gives me -80. 8 times 5 is 40. 4 times 5 is 20. 6 times 5 is 30. And 19 times 5 gives me 95. So that's giving me a scalar of 5. Okay, when we're looking at properties, you've done a lot of properties over the years. We've talked about commutative, associative. It's the same sort of idea. If I'm adding matrices, does it matter which one I put first? The answer to that is no. The associative property, if I have more than 3, more than 2, if I have 3 or more and I'm adding them, it doesn't matter which one I group together. I can do A and B first, or I can do B and C first. It doesn't matter. The order is not going to make a difference. So, and also similar to when you're distributing with a number, right? It doesn't matter if I have 4 times x plus 2, because that would give me 4x plus 8. Or if I had my monomial second, that would give me 4x plus 8 as well. You're still going to get the same sort of thing. Okay, so my left scalar and my right scalar doesn't really matter which side that scalar appears. All right, so let's do an example of these. So in this case, I'm given the matrix A and B, and it's telling me first to multiply. My scalar here is a negative number. It's -4. And then I'm going to subtract, again, 3A. So we can do this a couple, let's do this separately first. So let's start with my -4B. So I have -4 times -9. I'm sorry, -4 times -4. I was looking at A instead of B. That's my mistake. -4 times -4 is positive 16. -4 times -8 gives me positive 32. And then I have -4 times 8 gives me, I'm saying -4 times 2 gives me -8. And then -4 times -3 gives me positive 12. That's the first one. Now, you could do it a number of different ways. This is really I could say it's minus 3 times A, or I could say it's plus times -3A, right? Making my scalar either positive 3 or making it -3, and then using the correct symbol there. It doesn't matter. I think it's always easier to use addition. So I'm going to multiply A by -3. So -9 times -3 gives me positive 27. 12 times -3 gives me -36. 2 times -3 gives me -6. And -6 times -3 gives me positive 18. Now, because I decided to multiply that by the negative number, I now can add these matrices together, and the dimensions are the same. It's a 2 by 2. So my final answer here is 43. This is a -14. This is a -4, and that gives me 30. So that's my final answer here for -4B minus 3A. Okay, our last problem today is we're going to look at a word problem. And we're going to use a matrix. We're going to use a matrix to come up with the answer. So let's see what we have. It says the manager at the Miami location of the Coastal Sales Company would like to use their matrix to further analyze the representatives. The matrix shows the average daily wages and annual sales of all the representatives. So this is basically, when you're looking at the one matrix, it's basically like a table, right? So we have our average daily wages here, and we're talking about an entry, an assistant, an associate, and the same thing of our annual sales. Okay, so letter A. So what is the total average daily wage of the 3 types of employees? Total average. So if I add 900 and 2,400 and 2,700, I get $6,000. Right? This is 900 plus 2,400 plus 2,700. Letter B says, what's the total average annual sales of the employees? And that's the same thing. If I add 145,000 and I add 225,000, get rid of that, and I add 290,000, I'm going to get 660,000. So that's going to be my answer there. What's the average daily wages of all the employees? So now I go to the average daily. So now I'm going to have to take 900 plus 2,400 plus 2,700. I'm going to divide that by 3 because it's 3 different categories. And I have $2,000. That's the average. The average annual sales of the employees, same idea. I'm going to add these 3 together, and I'll divide it by 3. And I get 220,000. Would adding the rows provide a meaningful data for the managers? So what they mean is I have three different rows here. So it's saying if I add this together and if I added this together and this together, if I did that, would that be some sort of meaningful data? And it would not, because the columns are not related. One's talking about how much they get paid and one's talking about how much they sell. So the columns aren't related. Maybe if the columns just picked one or the other, if they talked about average sales maybe the month of January, or average sales the month of February, or average sales for the first quarter or the second quarter, maybe adding those together would be helpful, but we're talking about two different things here. And the last question here is, what is the average daily wages for the employees for a 5-day week? So if we take our average daily wage, which is $6,000, and we multiply that by 5, then we're going to get a total of $30,000 for a 5-day week. Okay, that's it for today. Thank you so much for stopping by. Have a great day.